Shall I say also my name or not needed?
Uh, yeah, your name, yes, I think that would be good. Yes. Good
Okay.
morning. Good morning, Anna. Can you please help us to understand a little bit about yourself and your background and how you came to be doing the things you're doing right now?
With pleasure. So my name is Ana Garcia Armada, and I am a professor at the university in Madrid. It's called Universidad Carlos III de Madrid, University Charles III of Madrid in Spain. And I'm doing teaching and research in telecommunications. And I also, at the moment, I am also the vice president of IEEE Communications Society, vice president of member and global activities. And as such, I have the opportunity to oversee many of the services we provide to all IEEE ComSoc members. I was previously the WISE chair. WISE is the Women in Communications Engineering Standing Committee. It's a very important committee in IEEE ComSoc that tries to promote the visibility and the roles of women in our career. And when I was the chair of WISE and also now as vice president of member and global activities, I had the opportunity to start several programs and events related to WISE activities, to do mentoring, to promote our young female engineers, and to offer them support for the development of their careers, because it is extremely important that they stay with us and they are successful in our field.
What brought you to the communications engineering field?
Well, when I was at high school, I was a very good student, and I loved math and physics, and I had very good marks. So it was kind of natural that I would go to some career that needed very high qualifications, and engineering was among them. At that time, I was fascinated by the radio, the satellites, the antennas, and I wanted to understand how all this magic worked. And at the same time, my parents, both my dad and my mother, were physics professors at the university, so they were quite close to the engineering field, and in particular to telecommunications, because they were close to the microwave and electronics. So it was physics, but the part of physics that is really close to telecommunication. So with all this, background, it was kind of natural that I was going to do telecommunication engineering. That was the most prestigious studies at that time for kids that were good in math and engineering, and were, anxious to understand the mysteries of how our world works. Eventually, what happened is, well, I studied, and I started later doing my PhD, doing research, and I started understanding all this magic of the telecommunications. And what happened is I became even more fascinated about all this. So I think the more you understand how complex and how beautiful it is, the more you liked it. And well, I think this is going to happen until, eventually I finish my career.
This is a really wonderful way to position the field. It's an attractive field, not only initially, but also the more you engage with the field, the more appealing it actually is once you come to understand the nuances, the details, and so forth. And also, for example, there may be some popular notions about the field or popular ideas about the field that make you communications interested. It's like a little bit of bait. But then once you get in, as any kind of student, whether it's a student who didn't recognize that telecom was a thing, telecommunications was a thing, once you are brought in to the periphery, then you see, oh my, there's, this application and that application and this other application, but they require the entire infrastructure in order for this to take place. Could you spend a couple moments explaining how you feel about the lifeblood of communications, as you mention it?
Yeah, because as I explained at the beginning, I was fascinated by the more maybe physical phenomenon. But later, I also understood how many applications we can run thanks to this telecommunications technology, right? So we are today in a society where we exchange constantly information and knowledge, and this is the basis of our society. And there are thousands of applications that people use and that have changed the way we live, the way we communicate, the way we study, the way we take care of ourselves because of these possibilities of communication. And sometimes we forget that, or we even take for granted that this is always happening, right? That you can always connect, that you can always have this information here or there. But this is because there are these powerful technologies underneath that are facilitating this possibility, and drones or robots or movies, all these is around us because of these powerful communications.
Thank you so much for explaining that. What do you regard as your most important technical contributions?
I think I'm most well known because of my first understanding and contributions to OFDM. OFDM is orthogonal frequency division multiplexing, and this is a kind of signal that today is used everywhere. But at the time I was doing my PhD thesis, it was not so well known, and we needed to understand how to transmit and to receive when we use the signal, and how the physical impairments that equipment have could be solved for this particular signal. More precisely, I work in phase noise or in the effects of nonlinear amplifiers, that were effects that needed to be understood and compensated in order to be able to use this signal, right? This is probably where my publications are most well known, but this happened a long time ago. After that, I continued in the evolution of OFDM, doing it multi-user, then combining it with multiple antennas, today with massive MIMO, and because OFDM continues and we need to keep adapting and improving it. And that could be probably my most technical, theoretical side, but I have always tried to use this knowledge I have of the physical behavior of communications to build systems. So I've been involved in many projects with many other people, companies, other experts in telecommunications, but maybe more in applications on other sides of the whole telecommunication stack, trying to use and understand how to use the new advances to help people, to help our society. So from I remember projects where we were communicating a car with a helicopter, with a satellite, to be able to provide coverage where there was no coverage. And this is a long time ago. Now this maybe it can be taken for granted. Or projects where we were trying to understand how we can better broadcast video in a mobile network. Or more recently, we had very nice projects about immersive music therapy and video in an elderly house, where people that are starting to get some neurodegenerative diseases can be helped with our communications, where they can be immersed in a scenario that reminds them when they were young, and they react much better to treatment. All these kind of things, of course, need OFDM, but they need many more applications, knowledge that I don't have myself, of course, all of it. But working with other people, I have learned a lot about the whole system view, and not only my particular piece where I am more expert. So this is what I find probably more exciting of this technical field, that is so broad, and you have the opportunity to collaborate with so many people. But of course, I am only real expert in some small piece of it.
I think what's really exciting about what you bring to this discussion right now is the fact that there's this interdisciplinary and interactive environment that you work in, and that you're able to model that to your students, to your peers, to inspire others to engage in that kind of dialogue, to learn things that you may not have known in the beginning and that others know, and that you can work with others to bring that skill into your project. This is a very inspiring opportunity for all of us. Do you have a moment to tell us a little bit about your work with Jerry Fashini and others, maybe Ronaldo or other people that we know?
Sure. Yeah, there was a time in the 2000 something, I understood I needed to apply my OFDM to MIMO. And where should I learn MIMO? Obviously, in Bell Labs with Reynaldo and Jerry Foschini. So I went there, and they were so kind to have me visiting there for, I think it was 4 months. But then again, next year I went again because, well, it was such a nice time. And I remember my first day when I arrived, and then Jerry started to explain to me the MIMO, and I was like, well, I cannot believe this. I mean, the creator of MIMO is explaining to me how he came to the idea. He was so nice that he was, I mean, probably many people have heard this, explaining to you how the math was talking, and the math was explaining to him, of course, not to me, how the system had to be built. Because looking at how the formulas, the equation were, it was clearly telling you how you needed to do the layered kind of MIMO thing. So this experience was amazing. I've been in other places that were amazing as well. I was also in Stanford when I wanted also to understand the multi-user OFDM. And then again, the place was to go and visit John Chaffee and understand it was the time when there was a lot of development in multi-user OFDM in DSL, but at the end it is the same for wireless. So yeah, I've been lucky to be inspired with many amazing people that at the end contribute also, of course, to a broader knowledge from my side.
And then at the same time, you can capture that experience and be mentored, be inspired by it, and pass it along to your students and your colleagues. And it rings forth in everything that you do, everything that you publish, everything that you discuss in this field. So thank you very much for sharing that. How has multi-frequency modulation contributed to broadband wireless communication?
Well, broadband means it's the blood of our communication, right? Because we need high bandwidth to be able to communicate fast, to offer a big data rate. And broadband had in the beginning a very important problem that we didn't understand how to solve, that was multipath. So communication comes from several obstacles, and this creates intersymbol interference. It creates a channel that we call frequency selective. And we didn't know how to communicate in this kind of channel. So broadband was not possible. It became possible because of OFDM. So with OFDM, something that was not possible became possible. And from communicating kilobit per second and perhaps 1-2 megabit per second, suddenly we were able to communicate hundreds of megabit per second and today gigabit per second on the air, all with OFDM. And this made possible the smartphone, it made possible everything we have today. And it probably will still make possible even the 6th generation of mobile communications, where we will have more than 1 gigabit per second deployed to our mobile phone or to whatever device we're going to have. So it was instrumental. Now we cannot think of any wireless communication standard that is broadband that doesn't use OFDM, and even the wireline as well. So all we have now is thanks to the possibility we had to solve that problem, and our understanding that multipath was really not a problem. It was something that could be even beneficial if you know how to deal with it, and we deal with it with OFDM or similar kind of technologies. So I cannot think of anything more important in the last maybe 20, 30 years in the field of communication than the not only invention, but understanding of the possibilities of this time frequency optimization and organization of the way we transmit, and how many other things came, like how we schedule, how the networks are designed in a way because there is OFDM underneath, and then the applications are possible because of that. So I think it's just amazing. I'm very proud to be a very small part of the community that managed to get this important invention to work, to be part of standards, and to be ubiquitously available today. And of course, this was thanks to the work of so many people in industry, in academia, so many years. And now I think we have a amazing knowledge of what we can do that was absolutely not possible 30 years ago.
Thank you so much for explaining how harnessing the power of something that had been considered to be an obstacle actually became a significant technological advantage. Do you think that equipment, devices, the progress of technology over those years may have helped bring these things into reach, that maybe there were other areas of technology that had to be mature in order for this to be possible?
Yes, electronics for sure. I mean, at the beginning, the original idea is from the 70s. Then someone had to realize this can be done with a fast Fourier transform. And then the electronics had to develop the fast digital signal processors that were able to really do a fast Fourier transform. So electronics are instrumental, and then once we were able to use this programming, because most of the communications have become a lot of software. Now everything is softwareized, and this makes things much easier, cheaper, reproducible. And at the end, all the telecommunications, I consider the telecommunication as a broad field encompassing electronics, computers, applications, because all of this has to be working together to be able to really have what we have today.
And as you mentioned during our discussion, our conversation earlier, people hear about artificial intelligence and they're intrigued by it, and it brings them into the space. It brings them into the space because it's so popularized. There are many, many tools now. Software is accessible and people want to be in the STEM field, et cetera. But that may actually be a gateway to help people enter into this field and explore these very important issues that you're discussing. Can you comment about that?
Yeah, because sometimes young people are attracted by the buzzwords, but something that is very popular. AI could be an example. And AI is a tool that is used in so many fields. And of course, it is used in communications, engineering, more and more, right? So if they are maybe attracted by this particular tool, but they find that the way we are using it is making possible new ways of communication, they will probably fall in love, as I did, with the communication technologies that are maybe more the basics, the essential technologies, a little bit more attached to how the physics of all this works.
And one of the nice things about being attached to the basic communication is that you can bring your passion with you, because you see the reality of the applications that are important to humans, to life, to people, to bringing communities together, to keeping in touch, all the things that are appealing to us as humans, I think.
Yeah, maybe you've heard this before, because I think I say it quite often, but what inspires me most is the smile of the people that use our technologies and communicate with the children, with the family, with the loved ones. And maybe now we are used to this, but this was not possible. I mean, this is because of the systems we have created that now make people closer to those that they love, and among others, right? And I think this is so powerful that, it's, to me, it's very, very inspiring.
Thank you. So Anna, what topics in our field are your students most interested in?
The general students that I see around me are very much impressed by the power of machine learning, artificial intelligence, and this is very general. However, when I go to my class, I see my students are still so engaged with the radio, the satellite, the optical fiber because of the light. There is some magic, I think, in this radio light, things that I think from the time we are children have, been questioning, inspiring and questioning us, and making us try to understand more, that I see the students are still amazed by the same things I was 30 years ago, which is interesting. I think this is the beauty of our technologies, that besides an evolution and the tools and so many things that we can use now that maybe were not possible in the past, there is some basic fundamentals that are very engaging. And I think the more you understand, the more you really enjoy them.
Thank you so much. So one of the things I hear you saying is that you see your own inspiration in the eyes and minds of your students. You see that you find that they have the same, that they reinforce the inspiration you saw when you were young. Do you find that that inspires you further in your pursuit of learning or innovating or pivoting? How do you see that inspiring you?
Yeah, I think when you see the people that surround you that are really inspired by the same that you are, I think it is more, you feel like you want to give more to them, and you want to understand and be able to explain and to inspire and to make it easier for the next generations to really keep advancing, because this is a constant race to advance more and more. And I think also, if I can communicate to them my love for the work I do, and I think sometimes I think I manage to do this, because I see their faces, and it is really clear that I am inspiring them. I think this is another way to contribute. I think it is not only our technical contributions, a paper I read, a new technology I can maybe invent. It is, empowering and inspiring the young generations to continue looking forward to more advances in our field. This is really very nice.
It's very nice. And the other thing that I see and hear from you and notice in your work and in your mentoring and inspiring presentations is that we, as older people, can still pivot. We can still learn more, and we can take the inspiration from these young people whose heart is in it too. They're inspired as well, and we learn from them. I think often we learn a new way of thinking from people who are younger because they have grown up in a different time with different needs. They didn't have the same, limitations we may have had when we were younger. So they're seeing a level set, like a foundation at a different place than we did when we were younger. And that by itself is inspiring. Can you speak to like the next half of our lives, or the others of our generation who perhaps could be inspired by these young people?
Yeah, absolutely. I think even the questions, when they ask something, they make you think twice about something that maybe you gave for granted, because at your time this was not a question, right? So they can even inspire new ways of creating the same kind of systems we have been created, but in a different way. I think it is now a time to rethink many things, because I think we reached a moment when we know a lot, but there is an evolution that took us to a certain way of doing things, and it's not necessarily the way that things have to be done. There may be new problems that need solutions, that maybe need us to go back 10, 20, 30 years and see, oh, we were doing this way, then we changed because of something, but maybe now we need to go back. And the questions of these people that didn't know are extremely useful to look for other ways to solve problems. And of course, it is extremely important to have also the people that have been doing all these years the systems, and then that can explain, inspire, avoid, repeating errors and mistakes that we have already done. And I think it is a field where, I mean, maybe it's in every field, I don't know, but in our field, it is extremely important to have the young and the old, the people with less and more experience, to work together in a synergistic way to really advance the field.
Absolutely. I think you're right. I think we can pivot from hearing these questions raised to us again by different voices, younger people, right? So that we can go back and say, what did we choose this path for? Why? Was it financial limitation? Was it lack of resources? Was it because the computers weren't sophisticated enough? Was it because we didn't have this easy to use AI? What were the reasons? And perhaps pivoting again, looking back, reflecting, thinking again, looking at what resources we have now, that helps all of us. And it helps keep us fresh as we mature in our life too, because we're no longer unengaged. We're no longer disengaged. We are now engaged in a discussion, a dialogue. Anna, where do you think our technical community have the largest role to play in the future of communications networking?
Well, there are so many unsolved problems. One very important is the sustainability. We need to make our technologies less power consumption. And another very important one is the ubiquitous, the way to include everybody, because we live in countries where we have all possible connectivity, but there are billions of people in the world that don't have access to internet, and this has to be solved. And I think another very important problem is to be able to communicate fully as human beings using our five senses, because we have more than voice and sight, right? And immersive communication, be able to really interact as we usually do, and not with a restricted portion of ourselves. These maybe are the three I consider most important challenges: sustainability, make technologies that can be sustained in time, taking care of our planet; including everybody, that means providing access where there is no access, and providing the senses, because some people maybe don't have the five, but for sure they have some. So if we make these communications immersive, we are also targeting, including everybody, and potentiating new ways of communication that are more human-like and less machine-like. That would be my three favorite.
What I hear you saying is that there's still a digital divide, and that there's still accessibility issues that aren't really part of the mainstream thinking. And in communication society, we're really called upon to bring that forward and to recognize it, to mention it, describe it, to define it, to iterate on those descriptions, to help our own community members in ComSoc and those who are curious of ComSoc, ComSoc curious, to help others to understand these issues, to work on them, to help describe them, to iterate them, and to resolve some of these most important sustainability and resilience questions for ourselves and for the future.
Yeah, I think sometimes we don't find the more technical point of these questions, and sometimes researchers are very much engaged in things that are very technical, but there are a lot of technical problems related to consuming less energy and covering everybody, that it's not only a policy or economical problem, but there are many other things. Actually, there are technical committees in the IEEE Communication Society trying to deal with this kind of aspects. So, and many researchers are now looking into ways to really get to all these billions of people that
And
are not
how
only in places, because maybe we are thinking of places that are very underdeveloped, but that's not true, because even in the most developed countries, there are areas where people don't have access to internet. So it's everywhere.
And we noticed that even during the pandemic, there were people in cities in the United States who were accustomed to getting access to internet when they went to work or by going to libraries and or to McDonald's. And then when the pandemic hit, they had no access at all, couldn't care for their own family members or communicate with relatives or get online to get information, even news information, which was important. And then, of course, there are many places where the broadband is not sufficient or people can't afford broadband. And so then, and on top of that, we have, catastrophic weather conditions that cause problems. And so there are many, many technical needs, as well as, like you mentioned, social needs. It's not just social and policy needs. And it's not just about, well, if you have the subscription, you have the service. It's really about providing for the community, providing, thought leadership and technical thought leadership that involves, like you were saying, making sure that the planet is cared for, that the power issues are part of the design, part of the thinking and the rollout. How can people who might be interested in that become more engaged in helping the future with these important questions about communications?
I think there are conferences that are very much pointing to these issues. Conferences from IEEE Communication Society for sure, because in future networks initiatives and connecting the unconnected, we have also programs. In my case, in my role of vice president of the Communication Society, I started, well, there was an idea, but I really managed to make it happen. And a program that is called Internet for All, with, I mean, not myself alone, with a team of people that are still working on it, and where ComSoc members can bring ideas of how they want to improve the connectivity of some particular area that doesn't have this connectivity, to build businesses, to improve their lives. So there are many opportunities. I know there are other fora that have also this kind of discussions, trying to merge the views of more technical or research people with industry people, with policymakers, with standards developers, trying to address these problems. I think these problems are multidisciplinary in nature, and it's not one person alone cannot really bring a solution, but we need discussion with many different actors.
Thank you so much for this time, Anna. Do you have some closing remarks you'd like to leave us with?
I think we are in a moment where communication technologies are going to be key in the future development of our society. And we are going to witness amazing new advances. And well, I think we are very fortunate to be one of the protagonists of this story that is going to take us who knows where, but I'm sure to places we even didn't imagine, as has happened in the last century. Who could guess we were going to experience the amazing communications that we have today? I think this is just the starting of an adventure that is going to continue.
In the
Thank you.
next year to 5 years, what would you personally like to see Communication Society achieve from that vision of the future you described?
I have a dream. When in the pandemic, it was very difficult. Many people were living alone and couldn't communicate at all, but we had internet and we had video, and people at least could talk and see their family, their loved ones. For the next pandemic, I hope we will be able to embrace each other through the distance with our powerful communications tools. And this is something I would like to see in the future, hopefully in the near future.
Thank you so much, and thank you for this fabulous interview. Bye.
Thank you.